Hello, welcome everyone. In this video, we are going to work on some examples about finding the intersection of two lines. So we're going to go ahead and start with this first example. We have the two lines here and we want to see if they are intersecting or not, and what is the point of intersection for these two lines. So first thing, let's say if the only time they don't intersect when they're parallel, for parallel lines, the slopes have to be the same. The slope of line 1 has to be equal to slope of the line 2. When this is the case, the two lines will not intersect at all. So let's go ahead and solve. This is a do not intersect. Don't intersect. Intersect because parallel. Parallel. All right, so the first line here, let's see what's the slope here. This is the slope m, and this is the y-intercept. We're only concerned about m, which is the slope of this line. So I'm going to mark it m1, which is 2. Now let's take a look at the second line. The second line is not in this format. So first we bring this second line into this format. We separate our y and x on each side of the equation. So we go ahead and add 4x. Add 4x here. So y, this 4x is gone because positive 4x, negative 4x are canceled out when you add them, and equals 4x plus 6. Okay. Now here, this is the m2, and this is the b, again, the y-intercept. So m2 equals 4. All right. So now we know that these slopes are not the same, so they're not parallel, so there is going to be an intersection of these two lines. So how do we find out? So when the two lines intersect, I'm just going to draw just a generic diagram like that. And then we have another one like that. Okay. So the point of intersection, the x and the y values are same for the both lines. So we take advantage of that. So wherever they intersect, the x and the y values are the same for 2. So for the x value, the y values are same for both lines. So that's why we're going to go ahead and do that. So we're going to basically set up our two equations equal to each other. So we're going to set y1 equals y2, because at the point of intersection, the y value is the same for both lines. So we know y1 is equal to 2x plus 2, and y2 is 4x plus 6. Okay. Now we go ahead and solve for x value. So that would be, we subtract 6 here. We want to separate our x's on one side and the numbers on the other side. So we subtract 6 from here. So we have 4x equals 2x. And when you add negative 6 and plus 4, you get negative 6 plus 2, you get negative 4. Okay. Now we basically bring our 2x on this side. So we subtract 2x from this side and on this side. So this is gone. You're left with negative 4 equals, when you subtract 2x from 4x, it's 4x minus 2x, you get 2x. And then you divide both sides by 2 to solve for x. So 2 cancels this 2, 2 times 2. So x equals negative 2. Okay. So this is the x value of the intersection. So okay. Now the next thing is finding the y value corresponding to this x value. Then we take this x value and plug in either in our y1 or y2. So this is y1, y1, y2, y2 right there. Okay, we plug in this and that will give us the y value that belongs to that x value. So we're going to go ahead and plug in here 2x plus 2, so y equals 2x plus 2 for x equals -2, we go ahead and solve for y. 2, -2 plus 2, this should be -4. When you multiply 2 with -2 is -4 plus 2 equals -2. So the y value is -2. So the point is -2 comma -2. That's the intersection of these two lines. So it would be like if you look at this here, yes, -1, -2, -1, -2. So this is the point where they would intersect both lines. All right. Now, if you want to verify that this is correct or not, you can also plug in this x value into the second equation. So we have y2 equals 4, and we plug in -2 there, and plus 6. So -8 here, when you multiply 4 by -2, and plus 6 here, you get -2. So you can verify using both equations, basically. When there's an intersection, the line, the point is going to be having same y value for both lines. Let's go ahead and work on the second example. Again, we have to know that if m1 equals m2, there's going to be no intersection because lines are parallel. Okay. No intersection. Okay. All right, now let's take a look at the slope here on our first one. First line. What's the slope here? Well, m equals 1/3. Now let's look at the second line. Second line is we have to simplify it, bring it in this form. So we basically add 3x. So y equals, this is cancelled, -3 and plus 3x when you add them, it becomes 0. And on the other side, we have 3x plus 4. Okay. Now these are and the slope here is 3. M equals 3. So m1 equals 1/3, m2 equals 3. So now we know that the lines are not parallel because slopes are different. So now we can go ahead and solve for the point of intersection. So to solve for the point of intersection, our first line, the y value has to be equal to the y value of the second line. So that's where they're intersecting. The y values are the same. So we go ahead and take a 1/3 x plus 2, that's our first line, and the second line is 3x plus 4. Now we go ahead and solve for this. To get rid of this 1/3, we have to multiply the whole equation by 3. So when we multiply this, 3 times 1/3 is just 1, so we're left with x here. And when 3 multiplies with 2, it becomes 6. On the other side, when you multiply 3 with 3, it becomes 9x. And when we multiply 3 with 4, it becomes 12. And we go ahead and simplify this. We bring x on one side and the numbers on the other side. So we're going to subtract x here and x here, 1x. This is cancelled. When you add a positive and a negative, it becomes 0. Here we have 6. And when you subtract an x from a 9x, you're left with 8x plus 12. And now we go ahead and simplify this further by subtracting 12 from each side because we want to separate or isolate our x. So it cancels here. So we have 8x on one side right here. And on the other side, we have 6 minus 12. You're left with -6. Now the next thing would be divide both sides by 8. So we have, this is equal to, when you simplify it, becomes -3/4. Now that's your x value. Now to find the y value, we can take this x value and plug in either in the first y1 or the second equation. So let's plug in into any of these. I'm going to plug in into this one. So y equals 3 for x, I'm going to put 3/4 plus 4. And then you go ahead and solve for it. So 3 times -3 is -9/4 plus 4. So you go ahead and take the common denominator. It's 4. This is -9 plus 4 times 4 is 16. So you're left with 7/4. So the point of intersection is your x value, which is -3/4, comma, the y value is 7/4. So that's the intersection of these two lines. All right, this would be it for this lecture. Hopefully it helps.